in 1 is to 25,000, what should be your contour interval then?
5 or 10.
It must be 5. Why? You are enlarging the area by 4 times, and therefore the accuracy level also should be 4 times. So we, in absence of this thing, we do. So and then your thickness of the contour becomes like this, and this is the contour thickness. Now many people I have seen here, the problem I am telling, what is the again difference between precision and accuracy? People georeference the topographic sheet, okay, and they try to enlarge it because they need not to plot the data, right? Thematic data, like very precisely, and then georeferencing, and they want to digitize the lithological boundary. While performing the georeferencing, they enlarge it and want to digitize like this. Some people create much more enlargement, 1:5 or 1:10 times enlargement, and go on digitizing like this. This does not enhance your accuracy. You are enhancing your precision. Precision does not help you to accuracy. Help you to enhance accuracy. Your base map is incorrect. How you are enlarging that? That is the problem. So, first of all, incorrect base map. First problem. Then map scale. When you are coming from regional scale to larger scale, same base map will not be sufficient to provide all topographic information. Okay. Now, what is the basic difference between topographic map and thematic map? Now, thematic map depends on your observation. It varies from person to person based on their experiences, their concept, their knowledge level, their attributes of thinking, attributes, so many things. Topographic map never changes because topographic map is near to the nature. You are portraying your nature through the topographic map. But when you are creating geological map, what you are doing? It is based on the personal knowledge, particular person's knowledge on the geology, and therefore, what practical problem you have seen, those people are working in compilation division, like compilation of Deccan tract flows with one topographic sheet with the other. Have you never seen this? This is the basic problem. So, I have seen one of my seniors is very, very sincere and accurate in observation, and only few meter thick he tried to portray on the map. No, this is also called semantic accuracy. In generalization, in cartography, there is a term generalization. There are two types of generalization. One is graphic generalization, one is semantic generalization. What is it? This is a practical problem you will face. Now there is one red gold bed which has got a very, very significant role in understanding the depositional environment or volcanic activity vis-a-vis the depositional environment, all sorts of things. So if you want to show the red gold bed of 1 meter thick or 50 centimeter thick or 10 centimeter thick, you cannot put it on 1:50,000 scale. So those are the problems. Then comes, then you have to generalize the map in 1:50,000 to 1:10,000. Sorry, 1:50,000 to 250,000. If you are to generalization, when generalization takes place? When the larger scale map gets reduced into regional map. Then you have to perform generalization. The generalization are two types I have told. One is graphic generalization. Graphic generalization can be done by anybody and everybody. Need not be the person of a geology, of a specific knowledge in geology of that particular area. Absolutely no. So what she or he will do? He or she will see if it is reduced by this way. These are the area. So have you done any generalization in GIS? Who has done? you have done. So we can give a command, if the polygon area is less than this much, has to be dissolved within the surrounding lithology or surrounding polygon. So you give a command, so that command will facilitate you to dissolve all the polygons of specific size or less than that to be dissolved within the surrounding polygons. That way, but some of the polygons or the linear features did not be dissolved, there has to be enhanced. So there are selection, enhancement and presentation is needed. So that comes, there comes the semantic accuracy or semantic generalization. Those are the ones. So data collection is a very tough thing, and data, particularly thematic data. If I am having very good topographic base, absolutely no problem. If topographic data cannot be changed by each and everybody, that is constant. Thematic, there is problem. Second data is that there are two types of data. One is nominal data, one is ordinal data. I think everybody knows it. You write, I will prepare a PowerPoint from you. We are representing our city. So something I speak today, I will forget tomorrow. So I have to prepare this PowerPoint. Depending on the situation, we need to give me this PowerPoint. So when you get the data, there are two types of thematic data. So one is topographic data and thematic data. I have told you the thematic data, depending on the observation parameters of the particular persons, it differs. Initial days, there was no perfect rule or SOP given to the geoscientists who are going to the field and taking data through their individual observation. These many parameters or attributes to be collected. Nowadays, through the SOP, we have advised them that you need to collect so many attributes. So everybody will be collecting so many attributes. Why it is necessary? It is necessary for the compilation of their data. So your spatial data with this much attribute, this spatial data with this much attribute has to be compiled. If you do not have the similar attribute types, you cannot compile them. It is impossible in GIS and all. So we are giving instruction. So this is tabular data. In a tabular data, we are handling how many types? I think you are in GIS, everybody has learned GIS a little bit, that's why I am not showing you. So you should have different types of attribute, and the character of individual attributes may be nominal and numeric. Your character, attribute character may be, when you are taking the lithology, you are writing the name of the lithology. So you are taking nominal attribute. In statistics it's called nominal. Another type called numeric attribute or ordinal attribute. This numeric attribute may be two types. One is integer, another is float. Good. So while taking the attribute also, you need to be very precise about the lithological unit. As for example, I am giving one this. You have observed this is the lithological unit, and you have got certain code of the specific lithological unit. So what type of numeric it will be? This will be integer or float? Lithological code. Everybody believes it? Integer, it must be integer. Area covered, float. So all sorts of things, area covered you cannot judge. What is GIS can do? Then color, textures, everything should be nominal. Likewise, you collect all the observation. While collecting the data, some of the observation are specific to a specific person. Color blindness, so I can also see something else what you see. So all sorts of things will be produced as an attribute, as a particular attribute which cannot be filtered to the latest section. Even if you filter into the latest section, you will not get the equal result for everybody. Okay. So those are the problems in thematic information. Now you write. I'm telling you to write because I will get it from you. What I am telling, I forget really. So this is the habit of me. Another type of data we are collecting. One is the data which we observe. So one is observable data, one is interpreted data. Now what is that? Who can give me the example of the very basic difference between the observable data and interpreted data? Prashant, tell me.
Observable mythology, law, structure.
Everything. I go to a certain place, I get the altitude. Okay, good. I went there, I got the altitude, I went there, got the altitude. That altitude is probably the perfect altitude with respect to mean sea level or with respect to what is the other reference scale? For elevation?
Basement.
You should know. Spheroid. So spheroidal height and geoidal height. So or local. So you take the height from each and every point. Can you go to all the parts of the earth, surface of the earth, and get the data of elevation? No, you cannot get. So you need to depend on, you have to create a surface, elevation surface based on observable data. And therefore you create some contour lines in your map. And those contours are interpreted data. You have taken fluoride concentration of water from different dark wells in your area, and based on the particular fluoride content in a particular location, you recalculate or interpret or predict the concentration of fluoride in other areas. So you can raster map. So those are the interpreted data. Now the interpreted data we will discuss, sometimes it will come. Today we are discussing in one platform and discussing the accuracy level of the data. We will go and see, if you go on interpreting the data like this, you get contour lines. Even if you do not get the contour lines, you get some raster data. So the interpolation is based on two mechanisms in GIS platform. One is based on vector line data, interpolated data, and another is raster. In raster, pixels will be given. This pixel will give different elevation from the other pixel based, and the size of the pixel will be based on the spatial resolution of the data set. So now you are part one, when you are observing, then also you are committing mistakes. Color or your observation criteria. Some आदमी क्यों कोई आदमी आके बोले यार ये तो white face वाला फेंक दो इसको. दूसरा आदमी जैसा हमारे बॉस थे, सीनियर थे, असिस्टेंट थे, वो तो तोड़ के आधा घंटा एक सैंपल का ऊपर देखेंगे, एक एक करके उसका मिनरलॉजी निकालेंगे, जितना उसका हाथ में होता है करते करते बेचारा भी खो दिया. तो ऐसा टाइप का हमारा we have one senior DDG, he was very sincere in observing things. He has also lost his eyes. So that's why I am not going to tell you, though you lost your you lose your eyes and all. Don't do that. And take it and see. If take help from others, there will be group one. Some people will be very good in petrography or hand facing study. So what I want to tell, the thematic map. The problem with thematic map based on the observation, it differs. Even if you observe correctly, then some of the maps you are going to produce contour maps. Those are interpolated maps, numeric values. If your observation differs from place to place, person to person, observation differs. Sometimes this type of observation will not be different. So the interpolation will be different. Then algorithm of interpolation. If you perform the interpolation with certain algorithm like IDW, inverse distance weight. If you give the weight 2, the contour pattern will be different. If you go for spline, contour pattern will be different. You'll see afterwards. And then if you go for Kriging method, geostatistical method, the contour will be different. Which is the best one? That is a matter of questions. So that also you need to know. So what I want to mean, you are not going to get the perfect result. It is not the truth. Contours are not the truth. I have committed a practical problem. When there is absence of GIS facilities, I had done lot of digitization of the contours and produced a digital elevation model. What wrong I did? What mistake did I commit? To the persons of GIS, it is a sin, it is a crime. Why? Who can tell? I have digitized the contour lines and on the basis of the digitization values of that. So I have created a lot of nodes over here and each node produces Z value of it. So X, Y and Z. X, Y is fixed and the Z will be created based on this contour value. Okay. Now what wrong did I perform? What mistake I committed? Very basic question. And therefore, nobody will ask you to get a digital elevation model. Huh?
Selection of method.
Very basic thing. You don't go for the details. It's very common sense you need. What is a contour? Is it an observable value or is it a predicted value? And the predicted value differs. The contour values differs from algorithm to algorithm. Not only algorithm, we will be discussing about the interpolation of contour creation depends on two things. One is geometry of the contour, geometry of interpolation, and another is algorithm of interpolation. We will discuss about very interesting something. So, all those things, all these mistakes we are committing. So, in nutshell, what we are doing? We are committing in thematic map. We are bound to commit mistakes in observable in taking observation. In thematic map, when you are depending on the interpolation of prediction, you are going to commit mistakes more and more. So these are the problems of data compilation. First, I will discuss of the compilation problem, and then comes how many geophysicists are there? 2 geophysicists. Thanks to national geophysical mapping, that's practical knowledge I have gathered. We are very happy. Yesterday, we had, with the help of some geophysicists, young geophysicists, they are very bright nowadays. We tried to interpolate magnetic anomaly and as well as gravity anomaly, gravity contour and total magnetic field. Those persons were helping us to understand the is a background geophysical values and the anomalous value, threshold values, all sorts of things, and the concept of interpolation of geophysical data. Because I am not expert in geophysics, so my theme is not geophysics. So till last year, all the geophysical maps which we got are the image map, and all are interpolated map in a particular algorithm with the help of software. So what is the value of that map? Absolutely no value to us for overlay analysis. We will come to overlay analysis or data integration. If somebody does not understand overlay analysis is a specific GIS term, then we will tell it is an integration, to integrate. So what is the basic difference between integration and compilation? Compilation of is lateral text. It takes laterally. Integration takes vertical. Have you understood? The 2 words will help you to understand the difference between the 2 aspects. Compilation are the spatial and attribute data of same thing, of same layer. You do that in geometrical division. And integration is a product of spatial analysis of the compiled thematic maps or thematic spatial and attribute data in different layers based on condition, logical condition, mathematical and trigonometrical conditions. What are the conditions? Now you have understood this is the things. It's a very tough time for Omniscient to write on all these things. Because ultimately I am going to take care of it. Okay. Should I repeat it then? Compilation